Hey everyone, this is Muhammad Nadeem and welcome to my YouTube channel. Today we will discuss about the transformer. Transformer is this device which is used to transfer the electrical power from one voltage and current level to another voltage and current level. So this transformer consists of the three main parts. One is this primary coil, the other one is this secondary coil, and the other one is this iron core. Okay, so this coil is called the primary coil because we will connect this coil with the AC supply, and this coil is called secondary coil because here in this secondary coil, due to the change in the magnetic flux of the primary coil, an EMF will be induced in this secondary coil. Okay, so here I am going to connect this primary coil with the AC supply. So this is actually the AC supply, and I am going to connect this primary coil with this AC supply. So now I have connected that. Okay, so as we know that this is actually the AC supply, and in most countries the alternating current, the frequency of the alternating current is 50 hertz. It means that 50 times in a second this AC supply change its polarity. Okay, so it means that the current, the direction of the current in this primary coil will be changes 50 times in a second. Okay, so due to the change in the current, the magnetic field, due to the current, the magnetic field will be produced in this primary coil. So here the current is changing 50 times in a second. So due to the change in the current, the poles of the magnetic field of this coil will also changes 50 times in a second. So due to change in the polarity of the magnetic field, the change in magnetic flux of this primary coil will be occur. So that change in magnetic flux of this primary coil will interact with this secondary coil. Now according to Faraday law of electromagnetic induction, the EMF will be induced in this secondary coil due to the change in magnetic flux of the primary coil. Okay, so here this coil, this secondary coil, do not connect it directly with this primary coil, but still the EMF will be induced in this secondary coil, and here I am going to test that while using this galvanometer. Okay, so here I am going to connect that, and it will show the deflection on the galvanometer. Okay, it will show the deflection on galvanometer. So here it shows the deflection on the galvanometer. Okay, so this secondary coil do not attach directly with this primary coil. So here the change in magnetic flux of the primary coil leads to the EMF in the secondary coil, and which is shown here by this galvanometer. So here if you focus on the needle of this galvanometer, it will be vibrating. Okay, so there it is vibrating now. This needle is actually vibrating. Okay, this needle is actually vibrating. It means that it show here that the polarity of the AC supply is changing 50 times in a second. Okay, due to which the change in magnetic flux of the primary coil will be occur 50 times in a second, due to which the EMF will be induced in the secondary coil, and according to Lenz's law, the induced EMF will always oppose the source, okay, that produce it. So here the change in magnetic flux produce the EMF in the secondary coil. So therefore the polarity, therefore the the polarity of this the current of this secondary coil will also changes 50 times in a second. Okay, due to which here this the needle of this galvanometer show the deflection or it vibrating about 50 times in a second. Okay, their vibration is 50 times in a second. So here I am going to zoom it. Okay, now see here, this is vibrating, this needle is vibrating. Okay, now I am going to disconnect it, it has stopped vibration. Okay, so there this needle is vibrating due to the AC supply. Okay, so in this case, if we provide the AC supply to this primary coil, okay, due to the change in the polarity of this AC current, the change in magnetic flux of this primary coil will be occur. Okay, that change in magnetic flux of this primary coil will interact with this primary coil. Okay, and also that change in magnetic flux of this primary coil will interact with this secondary coil as well. So the change, so here the change in magnetic flux of the primary coil is in this case the voltage, the change in magnetic flux of the primary coil in the is given by the Faraday law of electromagnetic induction, which is equal to minus n a primary del phi by del t. Okay, so this is the voltage induced in the primary coil itself. Okay, and now that change in magnetic flux of the primary coil also interact with this secondary coil. Okay, in this case the EMF in the secondary coil is given by the Faraday law of electromagnetic induction, which is equal to Ns and del phi by del t. Here Ns is the number of the turns in the secondary coil. Okay, so here we have this core, this iron core, and this iron core is actually support the magnetic field. Okay, so here the change in magnetic field will enhance by this iron core. Okay, and this iron core consists of the magnetic domain. So it consists of the domains, and inside the domain the electrons are in the same spin. Okay, due to the spinning of the electron, the magnetic field will be produced, and that the overall direction of the spinning, the magnetic field of the electron within the same domain will be the same. Okay, so if we provide the magnet to this iron core, okay, if we provide the magnet to this iron core, the domain, the direction of the spinning of the electrons will be aligned in the same direction. So due to which this iron core will behave as a permanent magnet. Okay, so if we remove the magnet from this iron core, this iron core will now do not behave as a permanent magnet. So this iron core is used here in this transformer in order to support the change in magnetic flux produced by this primary coil. So in this case, due to the presence of this iron core, the all change in magnetic flux in the primary coil will be interact with this secondary coil. Okay, so here this iron core will avoid the leakage of this magnetic flux. So therefore we can write here is that the EMF induced in the primary coil will be equal to the EMF induced in the secondary coil. Okay, so here in this case, this is actually the EMF induced in the primary coil, and we call this as a Vp, and here we call this as a Vs. So these two are equal, so therefore equation 1 and equation 2 will be equal. So equation 1 is Vp is equal to minus Np del phi by del t, which is equal to this, and we have to divide equation 1 and equation 2. So this is the equation 2 Vs, and here we will divide this side and s del phi by del t. Here in this case, this del phi by del t will be cancelled, because here the change in magnetic flux of the primary coil will be equal to the change in magnetic flux of this secondary coil due to the presence of this iron core, which support the change in magnetic flux, and it pass the overall change in magnetic flux of the primary coil this secondary coil. Okay, so due to this iron core, these two are equal, and we got that. So here this negative and this negative sign will be cancelled. Okay, so this become Vp by Vs is equal to Np divided by Ns. Okay, so from here we conclude that if the number of the turns of the primary coil is greater than the number of the turns of the secondary coil, in this case this transformer is called the step down transformer. So if Np or Vp is greater than Ns or Vs, then we call this as a step down transformer. Okay, so here this Vp is directly proportional to Np. So here if we increase the Np or Vp from this Ns or Vs, we call this as a step down transformer, and the step up transformer is when Ns or Vs is greater than Np or Vp. So we call this as a step up transformer. Okay, so in the transformer the power will be same. So power of the primary coil will equal to the power of the secondary coil. So power is equal to V I. Okay, so here this is Vp, Ip is equal to Vs Is. So from here we can write that Vp divided by Vs is equal to Is divided by Ip. So from here we conclude that voltage, okay, Vp is inversely proportional to Ip, and similarly Vs is inversely proportional to Is. Okay, so if we need higher current, okay, if we need higher current through the secondary coil, we will have to reduce the voltage. Okay, so we will have to reduce the voltage, and the reduction of the voltage is the job of the step down transformer. So in the step down transformer, the step down transformer decrease the voltage. So if we have more voltage, this step down transformer will decrease that voltage into that higher voltage into the lower voltage. Okay, and this transformer increase the current from the low current to the higher current, because here this Vs is inversely proportional to Is. So if this step down transformer decrease the voltage, it will increase the current. Okay, similarly this step up transformer increase the voltage. Okay, it increase the voltage from the low volt to the higher voltage. Okay, so if the voltage is increased, then the current will be reduced according to this equation. So if we need the lower current, we will use the step up transformer, and if we need the higher current, then we will use the step down transformer, and if we need the higher voltage, then we will use step up transformer, and if we need the lower voltage from the higher voltage, we will use step down transformer. So here do not confuse yourself. Here this V voltage is inversely proportional to the current, and in order to increase the voltage from the low voltage to higher voltage, we will use the step up transformer, and for the current we will use this step down transformer in order to increase the current. So here this voltage and the current will be inversely related. Okay, so we have this device which is called the step down transformer, and we know that step down transformer decrease the voltage from 220 volts to 0 volt or 3 volt or 6 volt, 9 volt and 12 volt. Okay, so it decreased the voltage from 220 voltage to this 6 voltage. Okay, so therefore it is called the step down transformer. And here in this diagram we have this coil. Okay, as I discussed that this is the primary coil and this is the secondary coil, and here in the secondary coil the number of the turns is less than the primary coil. So therefore this coil, this circuit is for the step down transformer, and if we provide the higher input voltage, it will convert that higher input voltage into the lower voltage. Okay, so here is the electromagnetic induction process occur between these two coils. So I am going to connect this device with the AC supply. So this is actually a transformer. Okay, so if I connect that with this AC supply, okay, this is now 220 volt, okay, AC supply, and here is the transformer. In the primary coil, the change in electric current will be occur 50 times in a second, mean that this AC will change its polarity 50 times in a second, due to which the EMF will be induced in this secondary coil according to Faraday's law of electromagnetic induction. And now according to the Lenz's law, this induced EMF will also change its polarity 50 times in a second. So here that more voltage, AC voltage, has converted to less AC voltage. So this is actually the AC voltage, and this is 3 volt, and this is come from this 220 volt, and this is the 6 volt, this is the 9 volt, and this is the 12 volt. So here this is the 3 volt. Okay, so this galvanometer show us the deflection, and for 6 volt this galvanometer show us the more deflection. For this 9 volt, the galvanometer show us more deflection, and for this 12 volt, this galvanometer show us the more deflection. Okay, so this is the practical of the step down transformer. The transformer used in our town is the step down transformer because that reduce the voltage from 11,000 volt to 220 volt. Okay, and similarly this is also the example of the step down transformer. And now where is the step up transformer is used? The step up transformer is used in the powerhouse. In powerhouse, if we produce the AC signal from the turbine, okay, we will increase that voltage from 220 volt or less volt to higher voltage. So for that we will use the step up transformer. So in the powerhouse we will use that step up transformer, and we convert the voltage into 11,000 volt or more than 11,000 volt. Okay, that will be supplied to the town, and in the towns we have this step down transformer, and again that higher voltage will be converted into the lower voltage. Okay, so this was the video about the transformer, and I hope you got my point, and that's it guys. Thanks for watching.